Okay, so here we have the LPP, which is a minimization problem, and we have how many constraints? We have 2 constraints. How many variables? We have 3 variables, that is x1, x2, and x3. Okay, so initially if you get an LPP like this, what will you do? You have to convert it into the canonical form. Okay, over here, can you tell me if it is the canonical form? We have the minimization problem. All the constraints are of greater than or equal to type itself. So we know that it is already of the canonical form. Okay. So we'll write the given primal LPP is in the canonical form. It is already in the canonical form. So next, what will you do? You will take the body matrix. Okay. Body of primal matrix. A is given by, can you tell me the coefficients? Here we have 1. Here I don't have x2, so I'll take it as 0. Okay, 0. x3 I have again 1. Okay, second constraint, I have 1, -1, and 2. Okay, so this is the body of the primal matrix. I'm going to take the transpose of that. Okay, so 1, 0, 1, 1, 0, 1. I'll write it vertical. Here I have 1, -1, 2. So it will be 1, -1, and 2. Okay, so since we got this much, how many constraints are there in the canonical form? There is 2 constraints. Okay, so how many variables will be there in the dual? There will be 2 variables. Okay, so since there are 2 constraints in the primal canonical form, we will have 2 variables in the dual, namely I'm taking it as W1 and W2. Okay, so since we have all this, we can go for the dual now. Okay, matrix, is there any problem? 1, 0, and okay, over here -1, no? Okay, here we have the first constraint is, okay, here we have the first constraint 1, x2, the coefficient of x2 is not there, so 0, x3 it is -1, so 1, 0, and -1. We take this in the vertical form, we have 1, 0, and -1. Thank you, Noel. Next one, we have the second constraint 1, -1, and 2. 1, -1, and 2, so 1, -1, and 2. Okay, hope it is clear now. Okay, so now we'll draw the dual. Okay, the dual LPP will be of the form. Here we have the minimization problem. It is minimization, so the dual will be maximize of z dash. Okay, maximize z dash is equal to, what are the right hand side of the constraints in the primal? It is 4 and 3. Okay, so here we'll have 4, 3. What are our variables? W1 and W2. Okay, next, subject to, what are the body of the coefficients? It is 1, 1, 0, -1, -1, and 2. Okay, what are the variables? W1 plus W2, 1 plus W2. Okay, it is a maximization problem. It is a maximization problem, so all the inequality will be of less than or equal to type. Okay, now we have to find the right hand side of the constraints. Right hand side of the constraints will be the coefficients in the objective function of the primal. Here we have 1, -1, and 1. Okay, so 1, -1, 1. Okay, finally the non-negativity constraints W1, W2, W3 all are greater than or equal to 0. Okay, once we have so much, what will we do? We'll go for the simplex table. Okay, here can you tell me, are we using the simplex table or are we using the just give me a second. Okay, are we going to use the simplex table or are we going to use the big M method? Okay, so before deciding that, there is one more thing that we have to check. before starting the simplex table, we have to check whether it is maximization problem. In our case, it is the maximization problem, so you don't have to worry. Okay, second thing what you have to decide is you have to check the right hand side of the constraints. Okay, right hand side of the constraints. Here we have a negative value, right? Negative value is there for the second constraint. So we have to convert this into the positive value. Okay, so I'll just take down that once again. Okay, since there is a negative value, the LPP has to be changed, okay, by multiplying the second constraint with -1. Okay, so the dual again changes. Okay. Here the dual is, the objective function will remain the same. Maximization of z dash is equal to 4w1 plus 3w2. Okay, subject to, the first constraint will remain the same, w1 plus w2 less than or equal to 1. Second constraint, we have a -1 in the constraint. So before using the simplex table, we have to convert this into +1. Okay, so multiply on both sides with -1. Here it is already 0 w1, so I'll ignore it. Minus of minus, it will be plus w2. So w2, the symbol will reverse. It will be greater than 1. Okay, here we have -1 into -1. So here we have 1. Okay, the third constraint will remain the same because it has a positive right hand side. Okay, minus w1 plus 2 into w2 less than or equal to 1. And the inequality constraints w3 are all greater than 0. Okay, only after reaching this stage, we have to decide whether to use the whether to use the simplex method or big M method. Okay, over here we have less than or equal to 1, but we have here greater than or equal to 1. So in this case, we will have to use the big M method. Okay, use the big M method. Okay, what will we do? Add surplus, slack, and artificial variables. Artificial variables. Okay, once we reach so much, I'll take down the objective function, that is max z dash is equal to, I'm taking down the same thing, to subject to w1 plus w2. Here we have less than or equal to, so we just need to add the slack variable. Okay, plus s1 is equal to 1. Second constraint, it is of greater than or equal to, so what will I do? W2 minus of, this is the surplus variable, I'm using s2 plus artificial variable a1 is equal to 1. Okay, the third constraint, minus w1 plus 2w2. Here it is again less than or equal to, so I'll add the slack variable. Okay, s1 which is equal to 1. Okay, then we have w1 comma w2 comma w3. We don't have w3, no, so s1 comma s2 comma a1. Okay, here we'll use s3. Okay, we have s3. a1 comma s3 all are greater than or equal to 0. Okay, once we reach so much, we'll go and draw the simplex table. Okay, simplex table, we have the Cj values here. Okay, once we have done all this, we have to add all these variables. Now I forgot, s1, s2, a1, s3 has to be added back into the objective function. Okay, plus, so here s1 will get a 0 as a coefficient. Here we have s2, s2 also will get 0 as the coefficient. Here we have s3, s3 will also get 0 as a coefficient. And then again we have an artificial variable a1. So it will get minus m as the coefficient. Then put a1. Okay, once that is done, we'll go for the basic simplex table. Cj is going to be the coefficients of the objective function. We have 4, 3, 0, 0, 0 and minus m. What are the variables? w1, w2, okay, s1, s2, s3 and a1. Okay, now what are the constraints? Take down the coefficients of each of the constraints. Here we have b, here we have cb, here xb, and over here the minimum ratio. Okay, here we have 1, 1, S1 is 1. We don't have the value for S2 in the first constraint. S3 is also 0. A1 was also 0. What is the value? XB will be 1. Okay, second constraint, W2 is the value, first value. So we don't have W1. We'll put a 0 here. Okay, W2 is 1. We don't have S1, put 0. S2 is minus 1. We don't have S3, 0. Then A1, we have 1. What is the value solution? 1. Okay. Third constraint, we have minus 1. We have W2 as 2. We don't have S1, 0. We don't have S2. We'll put 0. We have S3, that is 1. And we don't have A1. We'll put 0. Okay. And over here, we have the value 1. Okay. Now we have to decide the basic variables. Okay. Basic variables, we have to take the identity matrix. Over here, the identity matrix is formed by this one. 1, 0, 0, 0, 0, 1, and 0, 1, 0. Okay. First row, you have a 1 here. What is the variable? S1 and corresponding coefficient is 0. So in the first row, we'll write S1 coefficient 0. In the second row, where do we have 1? We have 1 over here. No? So take the variable corresponding to that A1 and minus m. So in the second row, we'll be writing A1 and minus m. Okay. In the third row, where do we have 1? We have 1 over here. The corresponding variable is S3. Yeah, and the corresponding coefficient is 0. Okay, so S3 over here and 0. Okay, please note over here, S2 is not there in the basic. Okay, because we are taking the basic variables according to the identity matrix. Okay, is it clear over here? Okay, in the second row, we have 1 in the last place. Okay, in the last place, we have the variable A1 corresponding coefficient is minus m. So we'll be writing over here. Okay, now we have Zj. Okay, Zj values, I'm writing it fast, 0, minus m, 0, m, 0, and minus m. Okay, then we have Zj minus Zj values. Okay, we have over here 4 minus 0, it is 4. Similarly, this will be 3 plus m. Okay, next one 0, this will be minus m, 0, and 0. Okay, then we have to check which is the greatest positive value. Here we have 4 and 3 plus m. Okay, 4 and 3 plus m. If you compare, which is the highest positive value? It is this value. Why? Because 3 plus m, right? You are going to check only the coefficient of the m value. Here we don't have the m value, so we will not take this. We'll be taking this as the greatest positive value. Okay, because our method itself is called as the big M method. No, big M means the m value is very, very big. So if you compare 3 plus m and 4, this value is going to be very, very big as compared to 4. Okay, you are only comparing the coefficients of m. Here do we have m value? No. So the coefficient of m value is 0 here. So 0, and here we have 1 as the coefficient of m. Okay, so what will happen? This is going to be the greatest positive value. Is it clear now? This is going to be the positive value. Okay, so our incoming vector is going to be W2. Okay, and what is our outgoing vector? For deciding the outgoing vector, we will XB divided by W2, which is our key column. Okay, next one. Here we have 1 divided by 1, that is 1. Again, here we have 1 divided by this 1, that is 1. Here we have 1 divided by 2, okay? That is 1 by 2. Okay, minimum ratio will be taking the least value. So, S3 is going to be the leaving vector. Okay, S3 will be the leaving vector and W2 will be the incoming vector. Okay. So, the incoming vector is W2. The leaving vector is going to be S3, and we have to perform the row operations. Okay, row operations, we'll start with the key row. Okay, that is R3 new is equal to R3 old divided by what is the key value? It is 2. Okay, next one, R1 new is going to be R1 old minus of what is the value corresponding to the first row? That is 1. 1 into R3 new. Okay, R3 new is our key row. Okay, then again R2 new is equal to R2 old minus what is the value corresponding to second row in the key column, that is 1. Okay, 1 into R3 new. Okay, do these operations. I'll go for the second iteration table. Okay, so Cj is going to be the same. We have 4, 3, 0, 0, 0 and minus m. The variables are going to be W1, W2, S1, S2, S3 and A1. Here we have B, here we have CB, XB and minimum ratio. Okay. The variables I'm going to write it down. Please do it for yourself. Okay. So in the first row, after doing the row operations, see R1 we have over here. No, R1 is equal to R1 old minus 1 into R3 new. Okay, I'm going to write the values of R1 new over here. Okay, it is 3 by 2, 0, 1, 0, minus 1 by 2, 0 and 1 by 2. Okay, here I have S1 and 0 now, so I'll write S1 and 0 itself there. Okay, second row, R2 new is equal to R2 old minus 1 into R3 new. I'm going to write the values of R2 new here to save time. Okay, 1 by 2, 0, 0, minus 1, minus 1 by 2, okay, 1 and 1 by 2. Okay, over here I have A1 and minus M. So here also I have A1 and minus M. Okay, next one, third row. What is our operation? Third row, R3 old divided by 2. Okay, I'm going to write the values there. Minus 1 by 2, 1, 0, 0, 1 by 2, 0 and here again 1 by 2. Here we have S3 is the outgoing vector, incoming vector is W2. The coefficient of W2 is 3. Okay, so W2 and 3. Okay, you will calculate Zj after that. Okay, Zj values will be minus 3 by 2 minus m by 2 over here 3, 0, m 3 by 2 plus m by 2. Here I will have minus m and here I will have 3 by 2 minus m by 2. Okay, now Cj minus Zj, Cj is this row minus Zj values I will have over here 11 by 2 plus m by 2, 0, 0, minus m, minus 3 by 2 minus m by 2. Over here I will have 0. Okay, have we reached the optimality condition? No, because here we are having positive values. Okay, 11 by 2 plus m by 2 is a positive value. Okay, the other all numbers are negative numbers. Over here it is 0, 0. This is minus m. This is minus 3 by 2 minus m by 2. Totally it is going to be a negative number and over here it is again 0. Okay, so we are going to take W1 as our incoming vector. We need to decide what is going to be the outgoing vector. Okay, for that we have xb divided by W1. Okay, 1 by 2 divided by, how will you write it? 1 by 2 divided by 3 by 2. So you can write it as 2 by 3 here. Okay, this value is 1 by 3. Okay, next one over here, it is 1 by 2 into 1 by 2. I can write it as 2. Okay, which is 1. Okay, over here it is 1 by 2 divided by minus value. Since it is a negative value in the key column, you don't have to write anything. Put a dash there. Okay, which is the minimum number ratio over here? The first row is going to have the minimum ratio. So S1 is going to be the leaving vector and W1 is going to be the entering vector. This will leave and this will come inside. Okay, so tell me the row operations for this. R1 new is going to be R1 old divided by what is the key element? 3 by 2. Similarly, R2 new is going to be R2 old minus of what is the value corresponding to the key column? That is 1 by 2 into R1 new. Okay. Similarly, okay, I'll stop it first. Okay. Next one, R3 new is equal to R3 old minus of what is the value? Key value 1 by 2. Okay. Into R1 new. We have only this one more table. Okay, then it will be over. So I'm not doing these operations now. I'll just directly go to the table. Okay. Okay, this is the second iteration table. Second simplex table, I have already the values here, so I'll just take it down fast. Cj is going to remain the same. Okay, here we have Cj. Okay, what are the coefficients of Cj? It is 4, 3, 0, 0, 0, and minus m. What are the variables? W1, W2, S1, S2, S3, and A1. Okay, here it is B, this is CB, this is XB, and here we have the minimum ratio. Okay, I'll take down the values first. Here we have 1, 0, 2 by 3, 0, minus 1 by 3, 0, and again 1 by 3. Over here I have W1 and 4. Okay, here I have A1 minus M. Okay, 0, 0, minus 1 by 3, minus 1, minus 1 by 3, 1, and 1 by 3. Here I have 3, W2, 0, 3 by 2, 1 by 3, 0, 1 by 3, 0, and 2 by 3. Then you will calculate the values of Zj. Zj values are 4, 9 divided by 2, 11 by 3 plus m by 3. Okay, over here I have m. Over here I have minus 1 by 3 plus m by 3. Okay, in this one I have 0. Okay, then Cj minus Zj values, I have 0. Here minus 3 by 2. Here I have minus 11 by 3 minus m by 3. Here it is minus m. This one is 1 by 3 minus m by 3. And the last one is minus m. Okay. This is one value. This is one value. This is one value. Okay. So now check the values. This is another value. Okay. This is one value and this is one value. Okay, so that you don't get confused. Now check the Cj minus Hj. All the values will be negative. 0. Okay, we don't have to consider. Then again, this is a negative number. This is also a negative number because we are having negative m. So this is entirely going to be a negative number. Again, this is m minus. So it is also a negative number. Then we have 1 by 3 minus m by 3. Just check the coefficient of m. It is negative. So this together is going to be a negative number. And the last number is also minus m. Okay, so this we have reached the optimality condition, but now go and check the basic solution. Okay, here we have W1, here we have A1. There is an artificial variable in the basic column. So what does that mean? In the optimality condition, if there is artificial variable, it means that this dual problem is infeasible. Okay, if the dual problem is infeasible, then what happens to the primal problem? It will be unbounded. Okay, according to the existence theorem. Okay, so then you have to write the answer. So since all Cj minus, don't leave the meeting. I'll just take 5 more minutes. Okay, since all Cj minus Hj values are less than or equal to 0 and artificial variables appear in the basic. So our dual problem, okay, therefore our dual problem is infeasible. So according to the existence theorem, according to existence theorem, the primal has bounded solution.